I'll describe the method to solve the exact differential equation. We have taken the definition that we having the function fxy. I say it is equal to constant. I take total differential of this one, and differential of this one is partial f by partial x dx plus partial f by partial y dy equal to 0. I take my differential form of the differential equation mxy dx plus nxy dy is equal to 0. So I will compare these two equations, this 1 and 2. So what we'll get? I'll get here partial f by partial x is equal to mxy, and partial f by partial y is equal to nxy. So I get here two equations. From these two equations, I will find the value of fxy. So here we differentiated it, then we're going to opposite, we're going to integrate it. We can start from any one of them. I start from here. I integrate partially with respect to x. I get here partial f by partial x into dx is equal to mxy into dx, and then I can just differentiate. I get here fxy is equal to integral mxy dx. Now here we're getting constant with respect to y, because we're integrating partially with respect to x. Y is constant, so I say this is my constant. Now I have this equation as, I just take this as equation 3 and this as equation 4. So we have used 3 but we have not used 4. So we use 4 and we'll get here the solution for the value for g of y. So what I do, I differentiate this with respect to y and put it here with respect to nxy. So I get here partial y using this 4 and 5. From 4 and 5, this is my 5. This is my 5. From equation 4 and 5, from equation 4 and equation 5, we'll find gy, and then we put the value of gy in 5, and that will be our solution. So I will show you with the help of example that how we can find how we can apply this one and find the solution. I'm going to take the same example which I was using to introduce this one, and we try to solve it, and we try to find, just to show that how the things are working. I'm just going to take this example. I want to solve this differential equation. This is my example. Solve the differential equation. My differential equation is here 3x squared plus 4xy into dx plus 2x squared plus 2y dy is equal to 0. So I can see here immediately, we can have here the solution of this one. First we check if this equation is exact or not. We write here my mxy is equal to 3x squared plus 4xy, and here I get here my nxy is equal to 2x squared plus 2y. Now I get here partial m by partial y with respect to x, with differential with respect to y 0, and here derivative of y is 1. We get here 4x, and get here partial n by partial x with respect to x. This will be 0. This will get here 4x. So we're having here partial m by partial y is equal to partial n by partial x. This implies differential equation is exact. Now this first step, that we're having the exact differential equation. Now if it's exact, then we come back to here and we can just write that if this is exact, then this holds. Then we can having here the value of partial f by partial x, and we having the value of partial f by partial y. So we can write here the values of the partial f by partial x. So I get here partial f by partial x is equal to mxy. What's my mxy? My mxy is 3x squared plus 4xy, and then partial f by partial y is equal to my nxy. This is 2x squared plus 2y. So here we start solving it. As I mentioned that we can start from the partial of partial x, we integrate this one, both the side with respect to x, and then we can have here the value, we integrate this one from respect to x, we integral partial f by partial x, partially with respect to x dx is equal to integral 3x squared plus 4xy into dx. So we get here fxy is equal to, integrate this one, this 3x cubed by 3 is cancelled with 3, you get here x cubed plus y is constant, x is constant, derivative of x is x squared by 2, so we get here 2x square y plus constant, as I said, the constant with respect to y, because we have taken partially with respect to x, we get constant with respect to y. So this is my equation here. I say this is my equation 1 and this is my equation 2. So I can use this equation 1 and equation 2 to find the value of gy. What I do? I'm going to take the derivative of this one with respect to y and then substitute here in 5. So write here partial f by partial y is equal to 0. With respect to y, get here 2x squared and get here dg by dy, because this is derivative of only function of y. So now I can just take here this one from equation 1. Now this is my 3, equation 1 and equation 3. What I'll get? I get here partial f partial y, partial f partial y. So get here 2x squared plus dg by dy is equal to, this here is 2x squared plus 2y. Now what's going to happen? So we're having here 2x squared is cancelled with 2x squared, these are cancelled, and we can write here the result as dg by dy is equal to 2y. I will get here dg is equal to 2y dy. I will integrate this one, so we get here gy is equal to y squared plus constant. I put the constant at the end here, and when write all the equations, I put the value of gy in equation 4 in 2. This is my equation 4. So from equation 2 and equation 4, from equation 2 and 4, I put the value of gy in equation 2, I get here fxy is equal to x cubed plus 2x square y plus y square. Now I put my constant. Now here I put my constant, I say this is equal to c. So my general solution is x cubed plus 2x square y plus y square is equal to constant c is general solution of the differential equation. So that's my idea, that whole I have developed and applied this one. I would like to revise with you that here we are having the idea that we're having the function fxy equal to c, like we get here the solution as fxy equal to c. So we take the total differential, that is partial of partial x dx, partial of partial y dy equal to 0. We compare it with our differential equation mxy dx plus nxy dy equal to 0. So this is partial f by partial x is mxy and partial f partial y is nxy, and we have already seen these equations are exact as partial m by partial y is equal to partial n by partial x. If this is not equal, then we can't apply this method. Now we try to solve from this equation 3 and 4 to find the value of xy. So we are going to take this one first, and we integrate both the sides with respect to x, partially with respect to, it's very important. When we integrate this fxy and here mxy dx plus, when we constant with respect to y. Why constant with respect to y? Because it was partial with respect to x. When I am going to differentiate partially with respect to x, then this will be derivative, this one will be 0. So we solve now, right? We having here partial f partial y, and here fxy, we use this, we have not used this one, we use this to solve our question. So I took this example and explain it, that we having this a differential equation in a differential form, So this is my mxy, this is my nxy. Now my partial m by partial y with respect to y, this is 0, derivative of y is 1, get 4x. With respect to x, y is constant, and we get here x, this is equal to 4x, y is constant, will be 0, so they are equal. Then we say differential equation is exact. So when the differential equation is exact, then we say partial f by partial x is equal to mxy, whereas my mxy is equal to 3x squared plus 4xy, and partial f by partial y is equal to nxy. So this is my 2x squared plus 4y. So at this stage, I am in position to find the value of fxy. Now I do the same. I take this part and I integrate with respect to x, partially with respect to x, taking y as constant. So I have partial f partial x dx, integral of this one dx. When you integrate it, here is fxy, integral of this one is x cubed by 3, 3 is cancelled with 3, we get x cubed, x squared by 2, 4 and y are constant, 2 is cancelled with 4, get 2xy, plus constant with respect to y, because y is treated as constant. Now here we want to find the value of gy and put the value of gy here, we get the solution. And to get this one, we have not used equation 1. So we use equation 1. We get the value of partial f partial y from this equation and put it here. So what is the partial f partial y? This constant 0. Derivative of y is 1, get 2x squared. Derivative of gy is dg by dy. So I can put it here. I'll get here the equation as 2x squared plus dg by dy is equal to x squared plus 2y. So they are cancelled. So my equation left is here, this one. We write the variable separable form, we integrate both the sides. I get the integral of g is equal to the function of gy. We get y squared. I'm not writing constant here. I can write it, but then I have to shift to the other side. So I substitute this value of this one in my equation 4. This was my equation 4, and this is my equation 4. Value from equation 4, I substitute here. I get fxy is x cubed to xy squared plus y squared. And we have taken that this is equal to a constant c. So we write here this fxy is equal to constant c, and this is our solution, x cubed plus 2x squared y plus y squared equal to c. This is my general solution. This was my example.